Have you ever just stopped and stared at one of those massive wind turbines spinning in the breeze, and wondered exactly how that simple, graceful movement actually transforms into the electrical energy powering, well, the very device you're watching this on right now? Today, we're doing an explainer on the mechanics of wind energy conversion. It is this absolutely fascinating journey of kinetic energy taking us from that very first gust of wind all the way to the plug in your wall.
Section 1. The bicycle analogy. Okay, let's dive into this and give ourselves a familiar mental map for the journey ahead. So think about this. What does a massive, highly complex industrial wind turbine actually have in common with your everyday bicycle? I know, it might seem like a huge stretch at first, but the core mechanical principles at play here are surprisingly familiar to all of us. Understanding this connection literally strips away any intimidation you might feel when looking at industrial engineering. Think about riding a bike. Your legs provide the raw power to turn the pedals, right? And then the chain transfers that mechanical motion directly to the wheel to propel you forward. Well, in the exact same way, the wind provides the power to turn a turbine's massive blades. That motion is then transferred right through the internal components straight to a generator. Honestly, it's essentially a giant wind-pedaled bicycle in the sky. Section 2. Catching the wind. Let's head to the very outside of the turbine, where the literal path of this kinetic energy actually begins.
Now, what's really interesting about this slide is how beautifully simple that initial interaction is. The blades, those massive aerodynamic structures sweeping through the air, they physically catch the wind's push. This forces the central hub, which we call the rotor, to turn. Just like your feet pushing down on your bike pedals, this right here is where the raw physical power of nature is first captured and forced into mechanical rotation.
But, as we all know, the wind doesn't just constantly blow in one single direction. So how on earth does the turbine keep spinning optimally? Well, it relies on a control system. This is a brilliant piece of smart tech that acts as a continuous tracking mechanism. It literally pivots the entire top of the machine, making absolutely sure the blades are always facing perfectly into the wind. It maximizes the overall efficiency so it never misses a breeze, constantly adapting to shifting weather patterns.
Section 3. Speeding things up. Now we're moving inside the machine, and the mechanical action is about to get really fast.
So that turning rotor we just talked about, it takes that energy baton and passes it right to a low-speed shaft. But here's the thing, a slow spin just isn't going to cut it for our power grid. Enter the gearbox. This is a critical mechanical component sitting right at the heart of the turbine, and its entire job is to drastically increase the speed of rotation. It basically bridges the gap between the slow, heavy sweep of the blades outside and the incredibly rapid movement required to actually generate electricity inside.
Let's move and see how this builds into a rapid chain reaction of kinetic energy. First, the rotor turns the low-speed shaft. Next, the gearbox takes that slow, heavy rotation and immediately ramps it up using a series of precisely engineered gears. Finally, this newly rapid rotation is directly transferred to the high-speed shaft, causing it to spin incredibly fast.
It's basically a massive mechanical multiplier. The gearbox takes what is a relatively slow rotation from those giant outside blades, and it multiplies its speed exponentially. We're talking about driving the high-speed shaft to rotate thousands of times per minute. This dramatic acceleration isn't just a bonus. It is absolutely crucial for the next stage of the process to even work.
Section 4. Generating the spark. We are now at the absolute core magic of the turbine, where this physical movement finally transforms into electricity.
Meet the generator. This is the machine entirely responsible for converting all that mechanical energy we've been building up into usable electrical energy. Mapping this right back to our bicycle analogy, if the blades are the pedals, well, the generator is the wheel. That rapidly spinning high-speed shaft drives the generator, tapping into electromagnetic principles to produce the actual, real-world power that we need.
So the crucial point is that this is a fundamental, almost magical transformation happening right inside the turbine's nacelle, which is just the name for that protective housing sitting way up at the very top of the tower. Mechanical energy literally transforms into electrical energy. The wind becomes motion, that motion gets multiplied, and finally that multiplied motion becomes the spark.
Section 5. Powering your home. Let's follow this newly created energy on its journey down the tower and out into our world.
Before it can travel very far, the electricity meets the transformer. And a transformer is exactly what it sounds like. It's a device that preps the electricity for a really long journey by significantly boosting its voltage.
It basically gives the power the extra muscle it needs to travel long distances across the grid without losing its strength along the way.
Think of it like a final relay race. Step 1, the transformer boosts the voltage right down near the base of the turbine. Step 2, that high-voltage electricity merges straight onto the vast network of power lines spanning across the landscape. And finally, Step 3, the energy arrives directly at our homes and businesses, powering the very screen you're looking at right now, ready to be used at the literal flip of a switch.
It's such an incredibly elegant journey, going from just a simple gust of wind to the power grid that lights up our entire lives. Next time you step outside and feel a strong breeze on your face, ask yourself, how much invisible power is swirling around us, just waiting to be captured? Thank you so much for joining me for this explainer. I really hope it completely changes the way you look at the wind.